Well, in this video, I want to do a side-by-side comparison of these two large format 12 volt, 460 amp hour lithium iron phosphate batteries from EPOCH Battery. Now, we've talked about some of the pros and cons of going with a larger format battery like this if you're considering doing a lithium battery upgrade. And we'll cover some of those again. But what I want to do in this video is really compare these two to introduce these two additional batteries to you. This is a very interesting comparison, I thought, because EPOCH Battery offers two of these large format batteries. They're both pretty similar in specifications, but this one, which you may have seen already, a lot of people talking about it online, this is their more premium battery that, you can tell it looks a little different. It's kind of cool. It's got this really nice case, and it also has BMS Communication, so you can connect it to your Victron monitoring system or potentially another inverter. This battery shares a lot of the same features as this one, so we'll go through what those are, but the difference is that this battery here, which is from their Essentials series, it's about $500 cheaper than this one. So what I want to do is go through some of the differences here, and we'll also crack open the tops of these and we'll see what's inside, and we'll do some testing and compare the power output of both batteries, and I'll let you decide for yourself which one will be better suited for you. Do you need all of the advanced features that this battery provides, or will this one do just fine? So looking across these two models, they appear to be very similar in terms of the ratings. Obviously, this one has all the communication capability, where this one doesn't. So all this stuff is the same. It's 12 volt system, 460 amp hours, and the overall watt hours is 5796 or so if you calculate that out of this. And yeah, both lithium iron phosphate, group 8D. We see a difference in weight. The premium one weighs a little bit more, like about 13 pounds more for this larger one, at 97 pounds versus 84 pounds for the other one. Our premium one has a higher discharge current, 300 amps. The BMS here in this Essentials one is a 200 amp, and our charge current's a little bit higher on this one here, the premium one, 230 amps versus 200. And our operating temperatures for charging are about the same. They're very close. And for discharging, they're also very close, if not the same. Waterproof rating, they're both IP67. So quick correction on the IP rating on this EPOCH Essentials battery. It's only IP54 rated. I just double checked the website, so it gives it a weatherproof rating and not a waterproof rating like the IP67. So only the premium one has the IP67 rating. This one's more of a weatherproof option. Sorry about that. One of the big differences here is that this premium model actually has the BMS Communication. It also comes with this pre-wired harness for all the communication. So we've got this one here, which has our Victron connection point here to go to our Servo GX, or our regular color GX module. It has some additional I guess RS-485 connections here too if you want to use that, and it comes with this this fuel gauge. Basically, it's a battery state of charge meter that you could mount somewhere else to just display the state of charge, and it's not driven off of voltage, it's driven off of the state of charge calculated by the BMS. So really nice to have this. And another piece that you have here is this remote power on button, and it has a indicator light here, and we'll fire that up, but yeah, it plugs into this side, and then you have a remote on and off button that comes with this battery as well. And they're both self-heating. They're Cycle life is pretty close, between 35 and 4,000 cycles, and they both carry an 11-year warranty. So this premium one here, $17.99. The more budget-friendly one, the Essentials model, is $12.99. And if you calculate the price per watt hour, we've got 31 cents per watt hour on the premium one, and about 22 cents per watt hour on the other one. All right, well, let's start by taking a look at this battery from their Essentials series. Now, this is the model 460Ah. I'm assuming the H stands for heated. So all the stickers and everything have all the essential information on here that you can see here. So yeah, pretty typical looking case that you would see in a battery this size. But yeah, keep in mind that this battery can replace like 4 to 5 100 amp hour lithium iron phosphate batteries. So we talked about some of the advantages of going with a larger form factor. And one of those advantages is you only need to hook up one battery and you don't have all the extra cabling and all the stuff that you would need to hook up multiple batteries to achieve the same output. So one of the big benefits, you know, we've got a couple of handles here which come in very handy because this is a heavy battery, and our terminals here at the top clearly labeled red for positive, black for negative, and these are M8 terminals. They come with these bolts already here. I tightened them down already, so we'll remove those in a second. And that's really about all we need to say about this case. Let's see if we can take the top off here and take a look inside. So we'll take a quick look here. The first thing I noticed that there's just a lot of sealant, so it made it a little bit tough to pry it open, which is a good thing. It's nice and sealed up. And you know, our BMS here on the top was covered by this this padding piece. But yeah, we definitely have the model number and the manufacturer information here on the top. It appears to be a JBD BMS, and it shows here it's a 200 amp BMS. I was able to connect to the battery using this Overkill solar app. This is not the EPOCH app. We'll look at that in a little bit, but you can see some stuff here. But the BMS, we've got our 4 cell groups, 3 temperature sensors, and if we look down here, the BMS manufacturer is JBD, and it's got the same model number here. So yeah, we've got a 200 amp JBD BMS. I was able to find it on their the JBD website. This is the 4S version, the 200 amp model for LFP. Yeah, that's the one. Listed here for about $111. So the Bluetooth connects here, and we've got some temperature sensors attached here, and this actually gets all connected probably through the sensors. It triggers the heating pad, which is, I believe, located on this side, and we can see we've got some of this padding off. There we go. Yeah, we've got strapping material and a fiberboard here, and a big metal compression plate on either side, keeping it all squeezed together. And it appears that the cells, all 8 of them, are actually mounted sideways. I kind of expected them to be vertical, but it looks like, you can see one of the cells here, it looks like they're actually mounted on their side, and the bus bars are on this side. So yeah, very interesting. I'm not going to tear it apart. Below that, we just want to take a peek in here and see what's going on. Yeah, I don't know if you can see this, but you can kind of see that we've got some bus bars here on this side of the battery, and I can see one on the very bottom as well as this one on the top. Got it all connected to the inverter now so we can do some testing, but I do want to mention that I've already done a full capacity test on this battery. When I got it, it was at about 50%, so I charged it all the way up to 100% until it wouldn't take anymore. And then I was hooked up through my my Victron shunt, and I was also monitoring it through the EPOCH app, which we'll show you in a minute. And then put a load on it and just let it run for many, many hours until it finally shut down. I believe it was down to like 10.7 volts when the BMS finally cut out. What we were testing for is to see if it would actually pull the full 460 amp hours out of the battery. And it did. It got up to like 464 when it finally shut down. So that was a good test. Now, what I'm going to do is to do a max discharge test to see how much energy we can pull out of this battery. Now, to do that, we're going to monitor it with the EPOCH app. So I'll show you how that works. And I've gone ahead and actually hooked up some thicker cables here. So this is a 4/0 cable hooked up to the inverter. For the capacity test, I could use smaller cable going through here because I wasn't pulling as much current during that test. But now I want to push the limits of it, and yeah, we need some thicker cable. I've got the EPOCH app set up on this tablet here, and you can see that as soon as I bring it up, it shows that this battery here has got some Bluetooth connectivity here. The interesting thing about the app is that you don't have to pair it. It automatically pairs through the app. So you just have to do this every time. So right now I'm going to turn this on, and what that'll do is it'll connect, and it's sitting at 13.3 volts. The BMS is reading 100%. And yeah, it's showing right now it's got like 458 amp hours out of the 460 or so. That doesn't really matter right now. Yeah. Not much difference here. If we go to cells, you can get some more information. It's tracking some averages here, but what we want to do is look at the individual cells. We can see they're all 3.336, 3.336, 3.335, so they're all pretty well balanced right now. And these down here are 3 temperature sensors. Yeah, sitting at about 73 to 75 degrees Fahrenheit. And that's pretty much what we got going on here through this app. Okay, so now let's do a max discharge test. Now, if you remember from looking at the BMS inside here and the ratings, this battery's rated at 200 amps continuous. So we're going to put a load on it to see how much we can pull from the battery and get at least 200 amps out of it. Now keep in mind that the battery also has a surge capacity of 400 amps. So who knows? We'll see what it does if we push it beyond the 200 amp mark. So I'm going to fire up my inverter here, and it's just going to be pulling from the battery. And right now, yeah, we don't have anything coming out of the battery. It's just at 0 amps. And I'm just going to start applying some resistive loads to this, and we'll see what we can do. Turn this one on. These are just some burners. Okay, inverter's coming alive. You can see we're already pulling, well, look at that. Already pulling 200 amps out of that. So the first part of the test is already successful. It'll just probably sit there like that. All right. 200 amps, no problem. Let's add more. Here we go. 300 amps, 315, a little bit more. Okay, that's just the inverter screaming a little bit. I'll take it down a notch. And we're pulling about 3,800 watts or volt amps from this, which is pretty impressive actually. Yeah, just sitting at 300 amps, no problem. Okay. Went down to 200 as one of these burners kicked off. $320. So yeah, pretty impressive so far. We're at almost 4,000 watts so far. 311 amps. It's just sitting there. Okay. Just went down to 215 as one of these burners kicked off. So yeah, pretty impressive. No problem. It's not heating up at all. Okay, successful test. Now this is a 3,000 watt inverter, by the way, and it's a low frequency inverter, so it can pull more than 3,000 watts. All right, let's shut it down. All right, so the Essentials battery tested pretty well. Now let's take a look at this one. You can see we've got the nicer case, obviously, and it's just got more stuff on it, some controls and so forth. So we've got some mounting points here on the bottom that are already threaded. So if you wanted to, bolt in some brackets or something to secure it down, they're already there. Very nice case. IP67 rated, so it's waterproof. I think I've even seen some video of them like submerging it as part of their testing. So we're not going to do that, but we'll take a close-up look at it. Now, one thing different about this battery is that the battery terminals are actually located in a different spot. So they're located more on the long side here. So we have our negative battery terminal here, and these are M8 sized bolts. So we got our negative here, and we have our positive here. If you remember on the other one, the battery terminals are located on the end. So that may make a difference in how you orient these if you have more than one. Okay, so we've got our power button and our dip switches, and it looks like these are all enclosed in like weatherproof little covers here. They got a little rubber seal around there. Now, this thing here is a vent. So we got a little vent here to vent air, I guess. I'm assuming it's kind of a one-way vent because you don't want water to go in if it's submerged. This is really nice in here. Now, the first thing I'm noticing here is that it's definitely not the same as the other battery. Yeah, we've got more going on here. Definitely a different BMS. Like this, first things first, let's see if we can find, oh, there it is. We'll get rid of this for a minute. Looks like some sort of heat insulation. So yeah, looks like we got a big heat sink right here on top of the BMS, but it has some numbers on it. Let's see if we can figure this out. Okay, I scanned the little barcode or the QR code here that's on the BMS and wrote down the numbers and tried to look it up. I couldn't find any information about this particular BMS. It's definitely different than the other one. So yeah, maybe it's just a custom BMS. Now it looks like this this heat sink is directly attached to, it looks like the MOSFETs are underneath it, so it's like making direct contact with those, keep them nice and cooled down. So I don't know how many are under there. But yeah, I'd like to take this off to look at the BMS more, but I see glue and stuff in there too, so I don't want to have to pry it open and destroy something, so I'll just leave it as is. Oh, it looks like the top here, you know that whole logo thing at the top? Looks like a big solid piece of aluminum here. So it's basically a giant heat sink. It's glued into there. And I'll bet when you put this lid down, it sits right on top of this thing. Oh, on top of this heat rubber thing. Probably transfers the heat right up through this heat sink out of the top of the battery. Look at this end. This is the big fuse that I knew was in here. People were talking about this big fuse. I think it's a 500 amp fuse. They said it's a T fuse, but it's not the kind of T fuse that we normally would get. So I think I have one. Hold on a second. Okay, here's a spare T fuse that I have for my setup. And yeah, it's definitely different. So look at the difference in size. Yeah, those aren't going to line up. So this is something different. So we'll see if we can find a source for that in case you need a spare. Pretty cool though. Look at these huge bus bars. Oh yeah, so these are pretty good size bus bars. It's like 1 1/8 by 1/16. And we got one on each side. So these are coming from our negative side. And so this must be the negative side. We've got some aluminum compression plates. And yeah, on this one, it looks like the strapping material goes around the outside this way. So the cells here, all 8 cells, are standing vertical on this one. So yeah, I can kind of see the corner of one of the cells. So yeah, so that's definitely the top of the cells, and you can see part of the bus bar. And we've got the positive bus bar coming out of this side, going through the fuse, and then the fuse goes to the positive battery terminal here, and the negative goes through the BMS. So everything goes down into the battery from here on this side. Oh, I can see this. So this white one, yeah, this white one here looks like it is for the heating pad. So I can kind of see where it's connected to the heating pad way down there. And it says here that we've got, yeah, 14.6 volts DC and 180.67 watts right there. So that must be our heating pad wire right there. And so the heating pad must be on this side of the battery. Right here, I can see where it's connected, so it's all along this side. And you can also see the seal, the rubber seal inside this lid here that matches up to this raised edge here on the lower part of the case, and that's what gives it its watertight capability. Now we have the battery hooked up to the inverter now with the 4-aught cable, and we're going to do a max discharge test on this one. I also did a capacity test on this one earlier, and the results were almost identical. So once I charged it all the way up and discharged it all the way down after a few hours, we were shooting for 460 amp hours of capacity draw, and again, just like the other one, it came out to about 464. So basically the same result as the other battery. So on that capacity comparison, they were identical. So now we'll do a discharge test. We'll throw some loads here and we'll see if we can reach the capacity of this for max discharge, which is 300 amps continuous and up to 500 amps, I believe, surge. So I can't generate 500 amps right now, so we'll have to see just how far we can take it. Okay, we're over 200. One more. 330. Okay, so there's our continuous rating so far. And yeah, if we go down here, that's over 4,000 watts. So yeah, we're pulling quite a bit right there, 335. Now the inverter is going to kick out because it's a 3,000 watt inverter and it's already pushing its capacity, but it's going to throw an alarm here in a minute when I turn this last one on. Ooh, hot. And the inverter's still cranking it out. Look at that. Yeah, it's about 5,000 watts, over 5,000 watts. Wow, pretty impressive. Just gonna let it go until it stops. You can be quiet now. Okay, the inverter just cut out. That's the flat line sound, right? Beep. Okay, wow, that was impressive. So it ran, what, over 400 amps, so 400 and some odd amps, close to, you know, over 5,000 watts. That's crazy. Okay, well, the big selling point for this battery is that it has BMS communication, specifically with your Victron system. So if you have a Victron system and you have a Serbo GX or a Color Control GX device, then you'll be able to connect the BMS inside the battery to your system so that the battery is going to basically feed your monitoring system all of the information that the BMS is tracking. So I'm going to show you how to do that here. Now, I don't have a Serbo handy for testing because my Serbo GX is in the RV currently being used, but I do have a Color Control GX device with a busted screen, and it basically works the same. It uses the same operating system as a Serbo, and it's gonna work just fine. So I'll show you what it takes to set this up and get it working, and then we'll talk about, you know, what you can do with it. All right, so the first thing is to take this wire harness that came with the battery, and you want to find the end that says INV on it. So I imagine that means inverter. So you're going to take that, and it's a kind of a standard network RJ45 cable looking end on it, and you're going to go to your Serbo GX, or in my case this Color Control GX, and plug it into the VE CAN port. Now on the Serbo GX it's probably going to say CAN slash BMS or something like that. So mine says VE CAN, and I have to do one more step in the settings to make it work. Here's the back of my device here. I'm going to take this cable and fish it back behind here so it just keeps it nice and tidy. And I'm going to plug it in right here. See, VE CAN. This is my CAN bus port. Okay. Now there's some discussion online on whether you need to terminate this or not. So basically telling the network here that this is the end of the line. And I don't know if you have to, but I have one of these terminators. I got a couple of these, so I'm gonna go ahead and use it. And I've been using it, so I know it works. All right, so it's plugged in here. You can see here that my GX device has a busted screen. Now, before I could get this to work, I had to do one more thing before connecting the BMS to the Victron system. Let me show you what that is. So the VE CAN connection, the port on the back of this device is kind of a multi-function port. So I have to go in and tell it what I'm using the CAN bus for, and I guess it has to change some stuff there in terms of how it's going to interpret that data. So let's go into the settings here, and I'll show you where that is. So once I'm in the settings, I go, let me get in here. We'll scroll down to all the way to the bottom, yeah, where it says services, and I'm going to click on that, and you'll see the fourth entry down here is, no, the last one, VE CAN port. I need to tell this what CAN bus profile I'm using. So I have it set to CAN bus BMS, so a BMS profile. Previously it was set to something else as a default, so, and it didn't work. But once I set it to this CAN bus BMS, then things started working. So just a note in case you are having issues. Let's go back and we'll go ahead and plug in the BMS and I'll show you what happens. So back at the device list screen, we can see that we have this test battery, which is our Victron shunt, and that's what it's currently displaying. And we want it to be connected to the EPOCH battery one, but it's not connected yet, so it says not connected. So we're going to take our cable here that's labeled Victron, and we're going to plug it into our CAN bus port here that has the blue cap on it. Victron, blue. So we'll plug it in, and then when we do that, we should see that this EPOCH battery is going to automatically pop up and start reporting data. So let's get it plugged in. We'll watch that. Oh, there we go. I see the little gauge started coming alive. So it's reporting our state of charge. And now we can see on the screen here that our EPOCH battery is reporting some information from the BMS. So success. So we can now take a look at what it's actually showing us through the Victron system right now. And we just scroll over and we've got our state of charge and battery temp. Under this details, we've got a bunch of cell voltage averages and temperatures. Let me see. We've got one battery installed. Yeah, so this is a useful thing, I guess. Alarms, if you have your system connected to the Victron system and an alarm goes off for some reason in the battery, like, I don't know, over voltage or under voltage, or temperature alarms, and it'll be reported through the Victron system and possibly alert you if you're monitoring it remotely. So it's kind of a nice thing. Right now we have no alarms, and yeah, it's just more alarms, some device information, setup parameters, and the like. So a lot of information that we can get from the battery now. But what we want to do is have it show up on the display here instead of the shunt. So to change the Victron display to now report the BMS settings from this battery as opposed to the shunt, we go back into our settings and get into system setup, and when we go down to battery monitor. So you can see right now the battery monitor is set to the smart shunt, and we want it to be set to the BMS here in the battery. So we'll just select that one, and automatically picked it up. Okay, so now if we go to our main screen, there we go. So now this information that we're getting here on our little chart is coming from the BMS in here as opposed to the smart shunt. So yeah, all set up. So that's pretty handy if you are using a Victron system for your off-grid setup, especially if you have somebody monitoring your system remotely. You know, having that information pass through the Victron environment and then shared on, you know, online through the VRM system, you know, that could be very useful. In fact, the way that this is set up right now, I'm connected through VRM through this this thing going through the internet, and this VRM connection on this cell phone here is pulling it from online and displaying it remotely. So this got this remote console feature. But you know, as I make changes here on the device, you know, I can see what's going on here on this screen. But it's taken a roundabout loop to get there, but it works pretty good. And yeah, that's what you got to do when you got a busted screen. Made it work though. So the big question is really, do you need the Victron BMS Communication? You know, I'll just give you my personal opinion. It's a nice feature to have, but is it required? No. You can certainly get by with a shunt connected to the negative output of your battery bank. Even if you have multiple batteries connected together, you know, these smart shunts are about, I don't know, just a little over $100 now. Pretty good deal, and they really do a lot. You know, in my experience, the only time I'd really want to look at cell voltages and internal temperatures and all of that other data about the battery is if I'm experiencing some sort of problem and I need to dig in and try to figure out what's wrong. Do I have a bad cell? You know, what's happening inside the battery? But for normal everyday operation, in my experience, I don't really look at it much. It just kind of works. I've never really had BMS communication, so I've really gotten used to it. So maybe that's where I'm coming from. But with the Bluetooth capability and the EPOCH app, the Bluetooth app, you can connect to the battery and get all that information. So when you need it, it is accessible. It's just that it's not displayed through the Victron app. And I think a shunt will give you a really accurate measurement of, you know, all the energy going out of your battery, energy going in. It's measuring it all the time, and it's been pretty accurate, and I trust it. But you know, so you have to ask yourself then, it's like, without the BMS communication, is the benefits of this more advanced battery worth the extra $500? So we've got a really nice case. We've got the waterproof feature. It's IP67. Got a lot of other features in here. We have a lot of we've got the overcurrent protection in the battery for that big fuse. The build quality in here is real solid. It can deliver a lot of power when you need it. So for me, I think it's probably worth the extra money to get this battery. But it doesn't say that the Essentials battery isn't going to work just fine as well. So it's really your call. My battery bank works just fine. It's 810 amp hours, and it's from another popular battery company in Nevada. Starts with a B, and I've never really had an issue, and it works just fine. I've been very happy with it. But it was a lot more expensive as opposed to this premium battery, which gives me more capacity if I had 2 of these than I do with 3 of these GC3 batteries that I currently have. And it would be about half the cost. So it's hard to ignore the cost savings that you get with these. And yeah, these are really good batteries. So what do you think? You know, let me know. Do you have these already? Are you thinking of getting them? Which one would you actually choose to fit your budget and needs? I'd love to know. So let me know in the comments. I'll join you down there and we'll talk about it. But thanks for watching, and I'll see you in the next one.